Hello everyone, Murat here, and today we are going to talk about and learn about how to build a vesting smart contract using Solidity language. Let's start with what is vesting, where it is used, etc., etc. I like it. Vesting is like um, money flows in a certain amount of time. Say, I like this example. Normally, uh, if you're an employee at a company, you get paid once a month, and that's it. Like if you run out of money in the middle of the month, you either like you are not in a good position. If your employer would pay you in a vesting schedule, you would be able to get the 15 days worth of your labor uh, at that time when you needed that money. Because it's been streamed to you. It's kind of like that. I really like it. Or like in another example, there can be a situation where you want to say that an airdrop or something like that in a protocol, you want to give your investors some sort of return, but you want them to wait for a while. Let's say you want to give your investors $100 in total of 100 days, but you want them to only be able to uh, claim their tokens, their money, after 50 days. Well, you can do that with vesting. There is this concept called cliff. We are gonna see it. It stops the users from claiming the tokens before the cliff is reached. There are many different strategies regarding the cliffs. Here we are going to check a quite basic one because this is a tutorial for learning. We are not going to write the code. I already wrote it today. We are just going to talk about it, see it, what's it doing, how it is going, etc., etc. I will share the GitHub repo with you. So after the tutorial, you can check it, you can play around with it. There's a small testing suite also. I didn't test everything. You can test yourself. It seems to be working. I didn't audit it. I work as a smart contract auditor, bug hunter, etc. Yeah, but I didn't like put too much effort on the security. You have to think about yourself. Let's see what's going on here. We are importing some OpenZeppelin contracts like interface for ERC20 tokens, safe ERC20, ownable, reentrancy guards, pausable, the ERC20 itself. Our vesting contract is ownable. It's taking from the extending ownable reentrancy guard pausable so that the owner can pause it. Um, we have the struct of vesting schedule. It contains UINT 256 total amount. What is UINT? It's in Solidity. It's unsigned integer, which basically means that it's a value between 0 and above. It cannot be negative, and 256, like, it's very 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 large number. So total amount of vesting schedule, start time, when did it start, cliff duration, we talked about cliff. It's calculated regarding the start time generally. Vesting duration, how much the vesting will take. Released, how much is claimed by the user or employee. Maybe I should have changed the name to claimed, but revoked. Well, the admin has the ability to revoke a vesting schedule. It can stop at any time. In this protocol, in our protocol, let's say um, you're an employer and you fired your employee um, in the middle of the month. They worked 15 days. They can get their money regarding those 15 days they worked, but they cannot get whatever will come afterwards. So it's fair. We have our mapping. You give the address. It shows the vesting schedule regarding that address. We have revoke timestamp. You will need that as vesting Boolean, we will need that. We have our events, they are needed for front end, other backend services, etc. In our constructor, we pass the address of USDC. It can be different regarding the chain. In Base, it will be different. In Ethereum, it will be different, etc. Ownable is the deployer of this contract, message sender. Pausable, pause functions, change owner, owner can change owner. Fund contract can only be called by the owner. So, you have to put some money to the contract so that the users can get their money. Let's check one of the most important functions. We already have only a couple of functions. As you can see, create vesting schedule, revoke, fund contract, withdraw access, funds, claim, etc. It takes address of the beneficiary, total amount, start time, cliff duration, vesting duration, and it can only be called by owner. Only the owner can create a vesting schedule. It wouldn't be really secure if anyone could create vesting schedule for themselves. They would basically be stealing money from the contract. We are checking if the basic checks, total amount should be greater than 0, duration should be greater than 0, beneficiary shouldn't be address 0. Here we are creating the vesting schedule struct. Start time, when the vesting will start. Released 0 because nothing is released. Maybe I should really change it. Nice. Anyway, we increment total allocated with the total amount that we are passing. Does the beneficiary has vesting now? Yes, they do. And we push the beneficiary to the beneficiaries array and emit an event. So here with the releasable amount that can be called by anyone, we are going to check how much can be released, how much can be claimed by the user. We are checking if the user has vesting. If not, return 0, because if you don't have vesting, you cannot claim anything. We are calling this vest amount function and then subtract what's already been released. This is important. I tested this around here. This seemed to be working, but you can test yourself. I'm here just to give you the basic idea. So let's see the vested amount function that's being called by releasable amount function. Vest amount again takes the address of the beneficiary, returns some amount. We get the vesting schedule. We have time elapsed and vested amount UN256 variables. So if there is no schedule, return 0. We had this here. Let's have it here too. Why not? If before cliff nothing is vested yet, so remember we talked about cliff. So um, $100 are vested for 100 days and the cliff is on 15th day. You cannot get any of the tokens on the 40th day. You have to wait at least at the day of 50. So we are checking that start time plus cliff duration. If block timestamp, actually we can change this to equal or smaller, but we are not gonna do that right now. This is like, this depends on what you want. Okay, let's keep it as it is. I mean, it will change a lot of things. This can be a bug depending on what you exactly want. Let me pause for a second. Yeah, let's continue with it. Let's not change anything. Again, this is, you have to think about this. You have to implement this. Is this correct or not? Do you want to, like, because this will change. This is about exact moment or before. You have to think about it. You have to decide about it. Here we have if revoked clause. So like if the vesting schedule was revoked, what is going to happen? We are checking the time elapsed um, for like what was the revoke timestamp, because it has been revoked. Let's see, there's a revoke function. Yeah, you see, it's only owner can call this revoke function, and it gives the revoked true and uses the block timestamp, which is now this block, for the beneficiary's revoke timestamp. Let's go back to, yeah, and we are calculating it with this calculation: total amount, time elapsed, uh, vesting duration. We have the vested amount, we get the vested amount. It's okay because we get the vested amount, the total vested amount, and we are remember, we are subtracting the released amount. So I don't see any problems here. There might be, I didn't do invariant testing, I didn't do much testing. Again, this is for learning purposes. Um, Here, if past the full vesting duration, everything is vested, and if not revoked, like, because if the vesting duration is finished, and if it's not revoked, because if it's revoked, we are returning early. uh, so if 100 days has passed, well, that means the vesting is over, the user can claim everything. um, If not, we are still in the vesting time. Calculate basically the same calculation. Calculate the time elapsed. This time from now, block time stop, and get the vested amount. So these checks are like the cardinal piece of the contract. You have to check how much they can get or not. Claim function can be called by anyone, but it checks uh, first. It calls the releasable amount function here, which will return zero, like, which will return zero if the user doesn't have anything, if they don't have a vesting schedule. So uh, nothing's gonna really happen. um or maybe something might happen, I don't know, I didn't test it. Go test it, write your own tests, play around with it, augment it, advance it, do some RG, I don't know, man, do something. um we are checking if they have some releasable tokens. If it's zero, like, there's nothing to release. Here, we get the releasable, and we are adding the releasable to the released uh, amount of the caller, because now it's released, and we are transferring the amount that they can get here and emit an event. Easy. We already talked about revoke function, uh, which the only the admin, the owner, calls. Withdraw excess funds. Um, this is basically only owner function, only the admin call it. What does it do? We get the USDC balance of addresses available to withdraw, contract balance, total allocated minus get total released. Um, so this is not an important function. I didn't even like spend 1 minute on it. Uh, just a second. Let me pause. Yeah. Sorry for the pause. It seems okay. Like, the idea, again, I didn't put much thought in it, but the idea is, let's say, I as the owner accidentally send too much USDC to the address than the amount that I want to send. Like, let's use numbers. Let's say I sent 100,000 tokens to the contract, but I'm only going to give 50,000 tokens, and 25 is already given. So 50 minus 25, 25,000, and the so that's gone. Uh, and let's say like simplify, the amount right now we have is 100,000. We struck 25,000 from 100,000, and we have 75,000 that is available to withdraw. The idea is the idea is so that it's the excess funds. I don't want to withdraw the amount that I have allocated for wasting. So now we are checking that, but we are getting the excess. This is like just a helper function. We can just even delete it. You don't maybe even don't want to use it. Here, our last function, um, we have a public view function that gets the total released, that loops over beneficiaries. And you see we have a note here: loops are a never good idea. Why loops are a never good idea? Because we don't know yet how many beneficiaries will be here. Maybe there will be thousands of them. I mean, in this contract we are basically controlling it, but it could be a completely automated DeFi style contract that we might not be able to know how many beneficiaries there will be. And this function, if it's ever used in anywhere important, which is, yeah, here, it's been used. So it can throw out of gas error, because this will get expensive if it's an unbounded array. Here not. A better way will be probably using mappings. I didn't, because this is a basic contract. I'm just letting you know that loops, like if you are writing loops in smart contracts, you have to be very careful. You have to think if this array is bounded or unbounded, because if the array can get large ad infinitum, at some point you will encounter an OOG, out of gas error. And that's pretty much it. We have some testing here, very 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 basic. I just like spent totally 1.5 hours maybe writing this contract, trying to show you how a vesting in the simplest term can be implemented in Solidity. I hope you liked it. As I said, go build something, do something with it. If you have questions, I probably won't be able to answer. But you have AI, you have everything. Go have fun. If you want to build something, uh, let me know. Yeah, that's it. Um, have a good day. I'm out. Ciao.